Welcome to EDU-VALUED Academy, where education is evaluated. Today, I have the basic and fundamental physical world of academy, that is number system. Number system, we have been nurturing these numbers since our LKG standard with the digits. And the world itself, the modern world itself, is a digital world. So here, number system, I have already divided this number into two categories. One is real number, another one is imaginary number. I am coming to imaginary number. Let me discuss the numbers which we have been nurturing since our LKG standard. Real number is again further divided into two categories. It is irrational number. Number consists of radical signs like surds, under root, or the exponent, fraction, positive fraction or negative fraction, whatever it is. Irrational number, it is non-terminating, non-recurring. We have the importance in division. Here we have non-terminating, non-recurring decimals if we go with division methods. Like if we want to find out the square root 2, it will never terminate. It will never reoccur. Neither recurring nor terminating. This type of numbers are irrational numbers. Now, let me focus on rational numbers. It is, in one word, it is in the form P upon Q, that is numerator upon denominator. But we cannot divide any number by 0, so there is a restriction. Q is not equal to 0. And P and Q are co-prime integers. This is the structure of rational number. Here you see, I have written 7 types of rational numbers, like whole numbers that you know well. We start with 0, 1, 2 and it progresses further. Natural numbers, it starts with 1, 2, 3 further progressing. Prime number having only 2 factors, itself and 1. It starts with 2, 2, 3, 5, 7, 11. This rate is progressing, having only 2 factors. Composite numbers having more than 2 factors, it starts from 4, 6, 8, 9, 10, 12. This rate is progressing, having more than 2 factors. Integers, later we have come to know, it is from negative infinity to positive infinity. So here minus 2, minus 1, 0, 1, 2, 3, that is progressing further. 6th category is fraction. It is only terminating denominators, must be 2, 5 or both or their multiples. That means a number will be completely divisible when the denominator, I mean Q, will be 2 or its multiples, 5 or its multiples, or 2 and 5 both or of their multiples. Then the number will be completely divisible, and that's why it is rational number is divided into terminating and non-terminating recurring. So this fraction is non-terminating, it is terminating, not non-terminating, it is terminating. And it will be terminating only when Q, that means the denominator, will be either 2, 5 or both or their multiples. Number 7 is decimals. We know 10 or exponents of 10 gives us the consonants of point, that is decimals. So those numbers all could be written in the form P upon Q. You see here you put 1 at the denominator, like natural number, whole number, prime number, these all are rational numbers. Now irrational numbers. Rational and irrational, so we have got it. And in rational key we have another part, that is non-terminating recurring. This is the case key when the denominator is a prime numbers besides or without 2 and 5. Because I already told 2 and 5 can divide a number completely. So besides 2 and 5 are also prime numbers. So besides 2 and 5, if there are any prime numbers at the division at the place of Q, then that will be non-terminating recurring. Like if I divide 1 upon 3, if I divide 1 by 3, it will give us 0.33333, will never terminate. So we put a bar, like the stick of police, stop. So we put a bar. This bar is indicating this 3 is repeated up to infinity. This way we have number system. Now I will tell you all about this one. Let me share this imaginary number. You might not have been introduced. You might have not been introduced with these numbers. Like when under root minus 4, if I talk about under root minus 4, we cannot give an answer to this question till 10 standard. Because we know square root of 4 is either plus 2 or minus 2. If I multiply plus 2 with plus 2, that will be 4, positive 4. And if I multiply minus 2 into minus 2, that is also positive 4. So definitely 4 under root 4 we know that is plus minus 2, but under root minus 4, product of two quantities will never give similar quantities with same sign, will never give us negative sign. So here is an imagination. We have already assumed I, that is representing imaginary number I, and its value we have imagined it is under root minus 1. See, if I say I is minus root 1, so then I can find out under root minus 4, because under root minus 1 is I, and under root 4 is plus minus 2. So I can write, this is your answer is plus minus 2i. Plus minus 2i. This is also, if I write minus 9, this is your plus minus 3i. Because I is under root minus 1, this is our assumption. This way we have imaginary number. Now root 2 having radical sign is an irrational number. How it is irrational? Let me prove. If I go with the division method, you see 1 1 the 1, 1 remainder. What I have used here, I have to add this one right here, keep a place. Take 2 zeros down. So far division method is considered for finding out square root. If we proceed this way, you see it is 1.41421, and it is non-terminating and even non-recurring. Since it is non-terminating, non-recurring, so root 2 is an irrational number. If we want to prove it this way also, we can prove. Let root 2 be a rational number in the form P upon Q, where Q is not equal to 0 and P and Q are co-prime. Squaring both sides, 2 P square upon Q square, cross multiply, P square is equal to 2Q square. So this expression is giving us the notion that 2 is a factor of P square. If 2 is a factor of P square, then definitely 2 will be the factor of P, that is by arithmetics. By the theory of arithmetic, 2 is also a factor of P. Let P is equal to then 12. If I put P is equal to 12 here, we have the equation again. We have 2Q square is equal to 2R whole square, 4R square. So 2 cancel. Q square is equal to 2R square. Like above, the same way, 2 is a factor of Q. Here we have got 2 is a factor of P, 2 is a factor of Q. So 2 is a common factor of both P and Q. This contradicts our assumption that P and Q are co-prime. We have already considered P and Q are co-prime. That means they do not have any common factor besides 1. So root 2 is rational. This way we have proved. This way we have proved it, and this is the way we can prove how a number could be an irrational one. Now here under root x into under root x, if the sorts are the same, like this is nothing is given, written, nothing is written to square root. For square root we know but two equal factors. One is root, so root x into root x is x. Simply this is under root, both the same, so under root x into x for two factors, one comes out. So this is our answer. Root x into root x is x. Similarly, I can say root 2 into root 2 is what? This is 2. This way. Same, root 3 into root 3 is 3. If I write 8 to the power 2 upon 3, then we have to go with the help of exponents. We have to have prime factors. This 8 is a composite number. If I convert it into prime factor, it is 2 to the power 3. So exponent rule, 2 to the power 3 whole 2 upon 3. So this is 2 to the power 3 into 2 to the power 3. 3 gets cancelled. It is 2 square. It is 2 square. This 2 is here. So 2 square is 4. 4 is the answer. Here also 4 to the power minus half. 4, 2 square. So 2 square means 2 into minus half. 2 gets cancelled. 2 to the power minus 1. And minus power means it is inverse 1 upon 2. But as we have root x into root x is x, but cube root of 2 into cube root of 2 is not 2. You see the condition. This is cube root of 2 into 2, 4, multiply, same such. And again it is 1 upon 3. So 4 to the power 1 upon 3 is the answer, not 2 or anything else. Here you see, if you don't understand, if it is the nth root of x, so this I can express in the exponential form, this x to the power 1 upon n. Exactly, root x I can write x to the power half. Now here is a question. Which one is greater? Root 4 or cube root of 7? To compare any surds, we have to go with the same surds. How to make these two surds same? Let me tell you. Here nothing is visible means 2 is here, 3 is here, take LCM, 2, 3 is 6. So I have to make it 6 root. To make it 6, we have to multiply by 3. If we multiply by 3, then the exponent of this term will be also 3. So that if I write in exponential form like this, 1 upon 3 or 3 upon 6, so this is 1 upon 2, the same steps will be there. Again, for this 3, I have to multiply 2. Once I multiply 2, I have to put a power also 2 here. So here it is 6th root of 64 and this is your 6th root of 49. Definitely root 4 is greater than cube root of 7. This is greater. This way we can compare the sets or irrational numbers. This is all about today. If you like and feel good, subscribe my channel, share it with your friends, relatives and your brothers. I hope this is the fundamental idea of number system. In my next class, I will solve few problems. Thank you.